Heidi-ho there. Geometric sequences part 1. Let's get it going. Okay, so geometric sequences are different from arithmetic ones. Arithmetic sequences are a pattern, and it's by adding something each time or subtracting something each time. Whereas a geometric has to do with multiplying by something each time, or really, no, that's just it. Multiplying by, it could be a fraction, it could be a big number, like a whole number. So that's what it's about. So right here, notice the difference between arithmetic and geometric. So with arithmetic, we had a common difference, right? With geometric, we're going to have a common ratio. Ratio means fraction, multiplication, division kind of thing. Okay, so let's go down here and let's talk about it. 5, 10, 20, 40. Easily you can say that you are multiplying by what? 5 times what is 10? 2. 10 times what is 20? 2. 20 times 40 is 20 times what is 40? 2. All right, so most of y'all can say that you can see it's multiplying by 2 to get each number in the next sequence. But what if you look at it and you cannot figure it out? You're just like, oh my god, what if they multiply by a fraction? This will be way more difficult, right? All you have to do is divide the second number by the first number, or the third number by the second number, and so on, to get the common ratio called R. So this looks real similar to the difference, except we are dividing. So it's a number divided by its previous number. So let's talk about this right here on this example too. What is the common ratio? So you're going to assume that these two are geometric and they're not crazy, right? So let's just talk about what would the common ratio be. So the ratio would be -4 divided by its previous number, which was -2. And in our case, that would get you 2. Right? Over here, it'd be -10 divided by its previous number, which is -20. And now pump the brakes. Pump the brakes. Some of you guys are going to tell me the answer here is 2. It is not 2. It is a half. Be careful. All right? There you go. By the way, forgot to remind you, I go pretty quickly. You know why I go quickly? Because this is in your control. You could pause me. You can go back and rewatch me. You can do whatever you need to do to get an A+. So utilize that, all right? It's your world. We're all living in it. So on this next part here, decide whether each sequence is geometric. Show verification by showing all the common ratios are the same. So you need to check every single one. I know you don't like that, but you got to do it, all right? So all of the ratios need to be the same. As soon as they are not, you need to stop and say, oh, this is not a geometric sequence or series, all right? So you just say, nope, not geometric. So let's check it out. So the first ratio would be 2 divided by its previous number, which is 1. We get 2. All right, so now we're going to take care of the 6 and the 2. So it would be 6 divided by its previous number, which is 2, and we get a 3. Uh-oh, sound the alarms. These are already different. They need to all be the same to be geometric. These are not the same, so it is not geometric. So that's what you say. Not geometric because the ratios are not all the same. As soon as you get a no, you can stop and say no. Okay? Let's look at this next one over here. So we've got the 9 and the 3. Don't forget, you can pause me if I'm going too fast. 9 divided by 3 is 3. Then we got the 9 and the 27. 27 divided by 9 gets us 3. Then we got the 27 and the 81. Goodness gracious. Do you know 81 divided by 27 off the top of your head? Don't just guesstimate. Just check it out. Let's see. 81 divided by 27. Is it 3? Woo! We're in business. All right. So this is 3. And we checked them all. So geometric because all the ratios are the same. There you go. All right, let's keep it moving. Getting used to those ratios. So over here we got a new formula. Now, hey, keep these formulas straight. Notice that the arithmetic formula has a D in it for common difference. A geometric formula has an R in it for a common ratio. So that's how you can tell the difference in the two, okay? Again, A sub 1 is going to be your first term, right? N, okay, remember, every teacher kind of says this one different. This is just how I say it. N is the place or term in the series, sequence, whatever. It's usually like something you want or something you know. Do you know the 10th term? N is 10. Do you want the 25th term? N is 25. It's all about the placement in the list of numbers. That's all it's about. And then R would be our ratio. Alright? There it is. Let's put formula on here again. Boom! Let's do it one more time. That way we don't have to go like this every 5 seconds. Oh, 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 oh. Alright? So, first term. This is the number or place in the sequence or series. And this one is the ratio. Man, I wrote really sloppy there. I apologize for that. It's really ugly. Okay, let's do it, y'all. Let's do it. So, given the following, find the following. Well, I already know I'm going to use this. Let's pop that down on our paper real quick. Okay. So, R is 2. Oh, goodness gracious. It's going to be pretty easy, right? So that's going to be 2. I know it's not going to be easy when you guys type it in the calculator. That's where things fall apart. All right, we got this right here. And then, well, hold up. Hold up. They said find A sub 12. They're being sneaky here. Do you see the sneakiness? What's N? Doesn't this usually say A sub N? They want A sub 12? What's A sub 12 mean? The 12th term, right? If I want the 12th term, N is the placement in the list. So the 12th term, N would be 12. So just keep in mind here what's happening, all right? You see that? Sneaky. So let's pop everything in there. So A sub 12 equals 4. Now here's where things get dicey. I tend to put 2 like this, and then because some calculators can differ, I'm going to do this, all right? So I'm going to type this in the calculator. Now, my calculator, hold on, I'll show you what I mean. Let me actually type it. My calculator, when I go up here, do you notice it actually puts it as an exponent? Some calculators don't do that. And you got to write parentheses. So you know what I'm going to do? I'm just going to write parentheses for the whole thing. That way, if you've got the older calculator, you're still going to get it right. Boom, there you go. The 12th term is 8,192. Now, real quick. Some of you would have thought you got the wrong answer because that's too big of a number. But when we are multiplying by a number each time, it grows very fast. Very fast. Some may say exponentially, right? Which is why we talked about exponential stuff earlier in class, okay? So this grows real fast, so you should be getting some really tiny or some really big numbers, okay? 8192. Let's see. Let's move on over here. Oh, every time I use a calculator, it wants to freeze my screen. It's very, very rude. So 8192. All right? Let's do it again. Let's do it again. So we know it's A sub n equals A sub 1 r to the n minus 1. Let's go on over here. What information did they give us? Oh, they're throwing some fractions at us. Are you ready for it? You can handle it. I'm just going to do some highlighting here. And you know, by the way, you could always highlight on your paper too. Go buy some highlighters. Use some crayons. It doesn't matter. Do what you need to do to get an A. That's all it's about. Again, they're being sneaky, right? A sub 6. So they're basically telling you n is 6. So don't get freaked out there. Okay? Just be real cognizant of that. So A sub 6 equals 32. I'm going to put this in parentheses. Please, just do that. And then I'm going to put this in parentheses. Just do it and you get it right every time. Okay? I just have people that don't. They do all the correct work. They type it in wrong and then wah. And it's sad. You know, no one wants to get it right after they've done all the correct work. -1. Well, that's kind of nice. That's pretty nice. So the 6th term is going to be -1. Look at that right there. It's a 6th term. Now, how you feeling? Feeling pretty good? Because we're about to get really deep. Your buddy. They said the following sequence was a geometric sequence. Do you believe him? Why or why not? Now, a lot of y'all will say yes or no and then write nothing else. Back it up. Back it up why you think that. So look, if this is a geometric sequence, if this is true, then all ratios must be the same. Right? If this is true, all ratios must be the same. So let's check out, oh boy, here. So we've got 25 over 15. Now you can go on and reduce that by hand. You can type it into the calculator. No one cares. You're just checking the ratios. Now I don't round because I just don't do that. I don't round. So I'm going to do this. So we got 5/3. Okay. Then I'm going to try the next two here. So we got 35 and 25. So 35 over 25. Put that in the calculator. 35 divided by 25. Oh, I don't think that's the same. That's definitely not 1.6, right? So we got 7/5. So I hate to inform your friend, your buddy, but your buddy's wrong. And let's tell him why. No, not all ratios are the same. All right? There you go. Let your buddy know. Let him know so he doesn't mess up again next time. All right? Hope you enjoyed this lesson. Until next time, goodbye.